JavaScript part, it's just writing a bunch of glue language to pass data between my clock and the brokerage. Yeah.
Make it full screen.
Sometimes it takes when it gets small, I'll use the mouse because sometimes it gets small. But JavaScript is the programming part is I would say it's actually pretty hacky. There's no real CS engineering behind the programming. It's just whatever I can do to get the job done. And JavaScript is just a hacky language to grab data from the brokerage and to put it to the second part, which is SQLite. That's where most of the data magic happens. For organizing all the data into tables and things. And then the C part, well, if I didn't have to do it, I wouldn't have used it. But there's a component of the trading system that it has to do like CPU calculations to figure out what it thinks, which stocks it thinks will do tomorrow, and which stocks will get that. And it just because I needed the most performance I could get out of it. It's written in C. If I didn't have to, I wouldn't have. But the C is actually it's written as a SQLite extension for SQLite. So you guys know SQL? All of you know SQLite, right? Yeah. So you can download SQLite as a vanilla binary from anywhere. You can just run anything on it. But because it has things, I have special things I need to run in C. I have to compile my own SQLite. So it's a custom build of SQLite. And so and now I'm just going to talk about each of the three components. So for the JavaScript part, right, the glue language. Every day it does this every day. It's actually twice every day. It will beginning in the morning and also at night. Actually around right now is what it looks like. We'll fetch about 1 gig of data from Yahoo Finance and TD Ameritrade for 10 years. It comprises 1,500 stocks and 10 years worth of data going back 10 years. And from this data, I'll explain next what happens in the next slide. And also every 15 seconds, it will fetch real-time quotes and prices from 1,500 stocks. That's about it has to make like 10 requests to the brokers to get all the other quotes. And also it's also fetching every single stock that I hold in my brokerage accounts. I currently have over 1,000 positions in my accounts. So and also every 15 seconds after it does some calculations, it can send up to 50 orders, execution orders to the brokerage for them to trade. Usually it won't be that high because when you go above 20, if you submit more than 20 orders, usually the brokerage will sort of error. They sort of break down. They can't handle to put that high. But sometimes if I need to suddenly like sell a bunch of things really fast, then I might do it. And also it's used, and then JavaScript is also used for some calculations, specifically calculating some technical indicators for the SPY stock. So the SQLite component, this is actually I would say this represents the majority of the code of the Tradebot. There's a lot of business logic in it. It's used to organize a bunch of things. Actually, I can give you more slide. So this is a SQLite table, SQLite database that just opened up. Make it a little bigger so you can see it. Probably hard to see. So these are all the tables. This database has around 43 tables. And each of these tables are taken on. So this first, I'm going so this is the states table is just it contains information about the the state of the current Tradebot. It has some things to deal with when it should execute spin trades or not. But I'll get into that later. This is the accounts table. So it shows the value of, I'll show you right now. So this is the account table. It has, I'm not going to show you the ID, but it has a bunch of things like the type amount. There you go. It has a bunch of data relating to each account. So my bot is currently trading around four different independent accounts. So it's showing four accounts right now, and it shows like how much cash is in each account, how much stock is in, how much value is off the top. And these are a bunch of parameters for each individual account, specifying like when it should, how much stock it should buy into the account in general aggregate, or how much it should sell off. I'll talk about these parameters a little bit later. And then there's a SQL table listing every single position I have, and that's this table right here. This table has, so as you can see right now, I currently have almost 700 different stock positions, spread over four different accounts. Yeah, the four accounts. One of them is the main one that's used to display or visualize all the dashboards. Two of them are private accounts I use personally. One of them is actually a small account. I've been experimenting with trading using an account that only has around $5,000. And the fourth account is actually someone else's friend, actually a friend of mine. I'm letting him use my trade bot for free. And then the next table is the orders table. This is a SQL table of every single active order that's pending right now. So I have currently around 1,000, almost 1,200 orders that are pending on the brokerage. These are all these are all orders currently to sell at a given price. And there's another table for all the orders that are closed. This is basically a history of every single stock I've sold. It's used. I use the history for telemetry to do some calculations in calculating when I should buy certain stocks and I should sell it. And there's also a table for that stores all the value calculated by the machine learning classifier that was written in C. It's this table right here. These three tables: feature key. Is my head blocking everything? Should I show right here? Or?
Doesn't matter.
Okay. Actually, yeah. Maybe I'm talking too fast, and none of you understand what's going on. Probably.
It's okay.
Yeah.
I'm kind of lost. So my question is like, I understand like you're going through like the accounting of it and how you know how many stocks you've got and where the trades are and whatever. How does it decide when to buy and when to sell?
Okay, we'll talk to that in the next slides.
Okay.
So yeah, these are these machine learning tables. Actually, yeah, it will take too long to explain which of these features are in the machine, so I'll skip that part. And then finally, like I say, most of the code is written in SQLite. It's the business logic code right here. There's around I would say about 8,000 lines of SQL queries in my bot. And then
you
finally,
actually implement the model in the database there?
yeah, it's written as an extension function to C.
Okay.
So the actual algorithm is just pure C, right? And then there's a wrapper also written in C, so you can call it as a quote standard SQLite function.
Okay.
How often do you update the model?
The model, it's updated every. You mean classifying every stock? It's classified every. It's reclassified every 75 seconds. Actually, it's explained right there. So the C component, right? So every day. Here, actually, about this. Go back to using. It's easier to show you the nuts.
What kind of learning approach did you do? Is it supervised and supervised?
Unsupervised. It's classification. Classifiers are always supervised. It's a very simple one. It's a 1D one, so because it's designed for speed, right? So
Classifiers can be supervised if you have attack learning.
okay, yeah, yeah, I guess. I'm not actually. I'm not that familiar with learning. I just found one that's really fast. I just optimized it super neat. I didn't really. Well, yeah, that's all. So every day, from the 1 gigabyte of stocks it downloads, it will try to make a prediction of what the market will do tomorrow, in the next 7 days, in the next month, next 30 days. This is set up a game plan for what it'll do. Set up a game plan for what it'll do tomorrow. So it always has a game plan when it starts a trading day. It doesn't just doesn't know what the hell it's doing. And this takes about 3 hours to calculate. And I can show it to you. It should be running right now.
What are the input data sets that you focus on? Is it just
Oh, it's-
prior history or?
Yeah, it's from, like I say, this thing right here, every day. When,
No, just historical trading?
yeah, some days, from that data right there. It will run a bunch of things.
When you say historical data, is it just price and volume?
Price, volume, open, close. So it's 6 data points. The volume, the open, the close, the low, and the high.
Per day.
It's been a long time, but I used to work at JP Morgan on the valuation side. Feed in a few more items if you want to get better trades. Try to feed in a little bit.
Okay. Well, it's actually, originally the bot was originally designed purely based on machine classification. And it performed meh. It basically underperformed the S&P 500. And over time, I found out it's more important to focus on trading execution. It's based on intraday, when based on the environment. It turns out.
The intraday trading
No. It
is
turns
really
out
good if you
no,
want
no.
to do like a high transactional thing.
No. What I mean is, originally the idea was, I would be smart enough to create a robot that could figure out, individually which stocks will go up and down tomorrow, right? And that might have been true maybe 5 years ago. It turns out that these days, because everything is linked to an ETF, everything is actually entirely completely correlated with basically spot, SPY. If a SPY goes down, whatever you pick, it doesn't matter. It's just gonna go up. When the SPY goes down, whatever you pick, it's just gonna go down. What you can do it, what the machine learning model can do now, basically, maybe it thinks when the SPY goes up, so the stock it picks might go up a little more than when the SPY goes up. But when the SPY goes down, it won't go down as much as the SPY. That's kind of what I'm using the machine learning model these days for. And then even that it's sort of mixed. So I use it, so the ML classifier, basically I use it to pick stocks and make sure they're not just complete dogs that do terrible. As long as it picks stocks that are reasonably within correlation with SPY, I'm happy with it.
Well, my focus was mostly on the commodity model, and so I would basically have developed models that were a little bit more sophisticated than just trading statistics. And there's a lot of seasonality in a lot of items.
Yeah, and those things are hard to programmatically automate.
Maybe we can reserve the commentary until after the talk and just.
You need to
Focus on questions.
Yeah, I wanna make sure you get through all your slides.
Yeah.
So the end of the day trades actually run on overflow, and if I can find it. This is a cron job that runs every hour, and when it hits a certain time, in the cron job, then it'll fire off the thing that does it. And runs it. If I can find it. Alright, I don't want to waste too much time, but it's basically it's highly automated, the system. like end of day calculations and everything. But so that's that part right there. And when you were asking about the classification, how does it? It does it every 75 seconds from the stock. And like I was saying, I sacrifice quality for speed. It's a 1D classifier. It's based on, the algorithm actually uses the derivative of the Jinx algorithm. The Jinx algorithm is basically, it tries to minimize the standard deviations. When you tell it you give a bunch of data to say I want maybe I want you to find like classify maybe 2 groups from it, and it would just set boundaries for 3 groups that has where the standard deviation for the standard reach group is minimized. So that's basically it. And yeah, 75 seconds. And also every 15 seconds it will calculate technical indicators for 1,500 stocks. And these are all the technical indicators. These are some of the feature sets it uses to feed into the machine learning classifier. And then of course it also does linear regression. It tries to see the general trend of the stock over the last 30 days, like what its beta is. So I just explained what each of those 3 languages did, and if I tie everything together, so basically the process of my trading goes like this. At the end of at 8 p.m. every day, this is all relative to New York City, NYSE time. That's when the all trading of stock ends. It'll kick off the end of day process. So let's try and find where it downloads the 1D data, tries to make a bunch of predictions for what the market will do over the next 30 days. And from that, it will create a trading plan for what it will do tomorrow. So tomorrow, beginning of the day, around 10 a.m. your time. This is 30 minutes after the market actually opens, because I want the market to get I want the bot to get at least 30 minutes of data from the opening trading session, so it has a better idea of where the market is going. It will re-download the 1 gig of data. It will redo the predictions, but not for 30 days, because that would take too long. It just does it for today and tomorrow. And it sort of validates that what it predicted yesterday is likely what will happen again today. And from that, it will set up a game plan. The game plan is basically telling is basically throughout the day, it sets a bracket of how many stocks it's allowed to hold, like how many. I'll show it to you when I actually run the bot. And every 15, and then okay, so that's the end of day, beginning of day. And then during regular trading session, which is 11 a.m. to 4 p.m., it will run a continuous cycle every 15 seconds, downloading data and then doing calculations on whether it thinks the market is oversold. And basically, based on whether the SPY is up or down, it will just make decisions whether to buy or sell stocks. Once it makes a decision to right here. Once it makes a decision to sell stocks, then it just starts selling things it holds that have the biggest percentage gain already. So it's basically sell high, right? If it makes a decision to buy stocks, then that's where the machine learning kicks in. So from every 75 seconds, the machine learning will provide it with a bunch of stocks it thinks it could buy that will go up tomorrow. So once it makes a decision to buy, it will pick some stocks from that pool. And they're all ranked and whatever. So that's how the bot works. I'm going over time, so I want to explain these parts, the next part. And like I explained, figuring out when to buy the stock. It's kind of, I think it might be too small for this. Okay. This is basically the SPY, right? The blue line is sort of the technical indicator. From all the it's sort of the equilibrium where it thinks the market should be. So when SPY is below the equilibrium line, that means the market is oversold, right? So in this area, it will start buying stocks that were picked by the machine, by the classifier. in the hopes that, it will return back to their equilibrium. And once it goes above the blue line, this is when it thinks the market is overbought. So this is where it will start selling its stuff. And I can actually show you this in my history. Okay, so this is actually the real-time data from today, right? So I'll pick out everything else. So you see this spot, right? So this is a spot, right? It's around right here. It sort of reaches low. So if there was an equilibrium line, it would probably below the equilibrium line. So around here, it would start buying stocks. If you look at the buy-sell history, it didn't buy anything. Okay, it sold a bunch of shorts. That's sort of akin to buying. But around right here, you will actually see a bunch. So each of these blue lines represents a tick where the bot actually bought a stock, and each of these red lines represent a tick where it actually sold a stock. And then here, when it went back up again, sort of, this is where I would think the market things are kind of it's a good time to start selling. So around here, you should see a bunch of red lines. So if I go back to buy sell history, it should be around right. No, I don't see any. Okay, the reason is that that's the case is because it's also there's another parameter that determines whether it's buy or sell stocks, and it's based on predictions. But I didn't have the time to explain it. I'll try to explain it when it's over, when time is over. Is everyone following? It might be. Am I going too fast?
No, you're fine on speed.
Okay. Right. Yeah, but that's sort
Are
of.
you mentioned that you do this with a database plugin. Have you shown the code for the database plugin?
Sure. It's a private repository, but I'm happy to show it on my.
Just the
computer.
interfacing, I think, would be enough.
I just prepare my camera.
Oh, there's okay. Actually, the interface is it's actually compiled into this thing right here.
But clarify for us which components are on GitHub and which are
Everything you see right now, this is proprietary right here. This is what you're seeing right now is database with my internal database that's used by SQL. This thing right here, this is public. This is just because this is just showing publicly what the Tradebot is doing. It doesn't show the internal tables like how it arrived. Yeah. I don't really care if you actually see my buy-sell history because it does so many trades. It did like almost 100 trades a day. Like if you want to shadow it, so this is public and this is private.
Where does this run? Local in the house, AWS server?
So like I showed you the workflows, it runs on GitHub.
Oh,
It's all in the
okay,
browser.
okay. Oh, okay, alright, thanks.
Right? This is all in the browser.
No.
there's a backend.
No. The browser is basically the dashboard. Okay, I'll show you. So what you see right here, this is in the browser, but this doesn't actually this doesn't actually affect the trading at all. This is not business logic. This is simply just visualization of what the bots do. Okay, and then this here. This is okay. See this job right here. Yeah, it just kicked off the end of day calculations for predictions for what's going to do tomorrow. And I'll show you. Okay, so this is the logs for this. It's a huge lot. Because I'm stingy, I don't want to pay money to run any of this infrastructure to pay it. This is actually running on a public open source repo, but it doesn't output any logs. So you don't know what's going on because a lot of it is proprietary information. What it does while it's running this is it will save the log, it will upload the log to private control. And I'm showing you proprietary information of the log of what it's doing right now. So what it's doing, what it does first is it grabs a bunch of financial data from Yahoo. It grabs all the indexes here, like particularly for SPY and IEV. And then here you see it's grabbing the historical data for all 1,500 stocks. So that's what this part here is right here. All of this. And then once it finishes doing that, then it kicks off the process. Right now, these are all numbers it's calculating for what it beats for its prediction model. And this will run off for around 3 hours. So the job just kicked off like 7 minutes ago. So after about 3 hours, this job should finish on GitHub workflows. But this is just an end of day job. The actual bot, I'll do it right now. It's right here. I just run it on my computer right now. It's running on. I could run it fine under Linux since it's a Linux. It's all written in Bash shell scripts for the running. So if you want to see me actually running the bot, okay, it's kicked off. And that's just the error handling right there. So because the brokerage is flaky, sometimes it will because I'm making so many requests to the brokerage, like around 2% of the time it will fail. The APIs will fail because of that. Actually, it's not feeding the data. Oh, here we go. So here it just did a trade. And so each of these things represents a count. I have 4 accounts, so you see 4 of these. 1, 2, 3, 4. And the thing that's important, the thing that's interesting here is this value right here. This represents a bracket. This is part of its game plan. It's the range of stocks it should buy, how much percentage of stocks it should hold or buy. So it says right here, you can see this number. It says it should hold more than 60 for this account. It should hold have more than 61% of its cash in its stocks, and less than 66% of it did. This is the actual value here. So right now it has 68% of its money invested in a bunch of stocks. If it goes outside this range, then it will start selling or buying to go back in the bracket.
I'm sorry, like I understand it's doing all this stuff, but I don't understand why. Like, what is it exploiting? I don't get like how you're making money in it or how you're outperforming the S&P.
Okay, I'll show you the data.
He's used a neural network to basically train it as best as he can when the shift will happen between downs and ups.
Yeah.
But I mean, is
Okay,
that,
so the thing is
so
that
it's
he doesn't
right here.
even know how, because he used a neural network and he trained it past historical data.
but is that a sound idea? Like, is there actually a pattern to that? Is that a neural net can learn?
It's very rare that you can actually use this long term to make lots of money.
So this is actually this is 2 years worth of actual data, real data. So this blue line here, this blue line here is basically SPY over the last 2 years, starting from March 2021 all the way through to present, February 2023. So you see it went high around, the high point of SPY was around December 2021, and then the low point here is when they're October 2022. And now I'm going to show you overlay basically my bot, so you see how it performs. So this is the bot. So when the SPY goes up, the bot also goes up, but not as much. And when SPY goes down, the bot also goes down, but not as much. And after at the end of this period, SPY is up 3%, and the bot is up 7%. So it's feeding this. It's been.
But
feeding
you trained that bot over the exact same data set that you're comparing against, correct?
Yeah. What?
Well, that's a machine learning.
No.
model.
This.
But this is historical. This is not.
Yeah, it doesn't
Okay.
matter, it's fine if you wanted to use it to do historical data. Okay, if he's trying to make sure that like his machine can predict a historical value, that's fine. But there is a different set of statistics that's used for projections, which basically does not include all of the data. And if you're trying to do machine learning, then you need to reserve some of your data set
Backtesting.
for verification.
just to
You
get to what I
why
think
is it historic?
Ed's point is like really, really easy question. The two lines that you're showing us, did the line that's red, your bot, did it have knowledge of the line that's blue before it did the drawing?
No. This is actually my brokerage account. This is my brokerage account trading on the bot. This is what my bot is actually. This is actually real money I'm making with you. So right now,
Okay,
I'm.
but that's not the question Evan asked.
I'm sorry.
They didn't know ahead of time, how could it?
Yeah,
They made
how
this
would
trade
I know ahead of time? It's
They made this trade then.
But for each point, it's trading almost up to that point, right, using that data?
Yeah, this is not
Okay, so
backtested data.
so I see, the red line was actually generated in real time.
It's real time, so, yeah.
Okay.
But it's got the information that trails behind the red, the
So-
red line has the
yeah.
information from the blue line that's trailing behind just 75 seconds,
Yeah,
right?
yeah. No.
No, 1 day, isn't it?
This is over, no, it knows everything 10 years in the past. So at this point right here, the red line, it knows everything, I'm sorry,
So, I
The
saw
red
this-
line is the run of his neural network
at this point
against
right now,
current trading.
it knows everything back here in the past. And this is how I actually perform at this point. This is in the future, it doesn't know anything about it. Does that make sense?
Yes.
For that point.
Yeah.
At this
But-
point right here.
I've seen this, I saw this talk once before, and when I heard it the first time, I did ask these questions, why is this a good theory? But like today, it is outperforming, but hypothetically, let's say it's not outperforming. It doesn't negate the value at the top if it underperformed, because it's code, it's working.
Right, and if you
It's
take a
gonna do
look,
whatever the creator wants it to do or not do.
and if you take a look at it, it's statistically underperformed about 50% of the time. Now, recently, it's overperforming, but if you take a look at the
Yeah,
historical time.
but there are certain clients who might prefer underperformance in certain times, and some people prefer overperformance other times. People have different portfolios, different
Actually,
monetary value.
the one they care about most is the Sharpe ratio, basically the volatility. But like you want if something has the same returns, but the one has a lower volatility, then that's way better.
You're buying down risk, yeah.
And if you want to compare actually to the thing, the thing it's most closely mirrors is not the spot, it's actually the Dow Jones.
Yeah, and the thing is that your model doesn't basically have any risk management built in, which is pretty much what you would really want if you were going to use it.
But you can derive that just by looking at the historical Sharpe ratio.
But
And if you look at the Sharpe,
You can always look at the historical risk after it happened, but you're doing a predictive estimate, so you need to have a predictive risk.
I'll take that point. I'll agree to that.
like the bot can be improved on, right? Because it's a one-man project. But the
Right.
point is, it's working now, and it's in production.
Yeah.
So if people want to, I don't know if you're letting other people look at the code or not, but the point is, anything that's missing can be added, and it's in production now and working.
And
Whether
I
it's
think,
doing what you want it.
I think for a lot of this group, since this is not really a finance group,
Yeah.
okay,
I
what
feel like
would
you
be
get away with it.
more useful to the group is to talk about machine learning, how you develop your model, things like that, how you have the software that supports it. If you want to go into like the financial trading side of it, there are some people that are interested in money, but that's not going to be nearly as interesting to the people as the technology of how you develop a model, how you make it predictive, things
Well,
like
it's
that.
subjective too. You can't say that there's less value because we're focusing on the financial aspect of this model. I mean, no one really gives a shit about calculus, but the first thing we all ask when we learn it in high school is, when am I ever going to need this? There's no figure. This is the exact scenario.
I'll be happy
I'll
to explain the actual predictive.
Yeah, because I mean, some people might walk away with something else that they want to say predict using a
But-
learning model.
That's
I'll
fine.
tell you what I got out of the first time I heard this, and that is, it's easy to grab, the APIs are easy to grab the data, and the APIs are easy to execute trades. So anybody with a normal brokerage account can request API access and start putting trades in automatically.
The only sound financial advice is buy GameStop and hold with diamond hands.
Yes. You're a genius. Follow that advice.
Thank you.
If you do that,
Thank you.
You'll only go up.
The moon.
But okay. This is the GitHub repo. This contains all the source code, including the predictive things. It has no dependencies. It was all written with 0 dependencies. And this here is the actual the C code you see right here. Written in C is the actual machine learning classifier. It's about it's 900 lines of code. And like I said before, it just it minimizes the standard deviation between groups across the 1D line. And so the machine classifier is 900 lines of C code. And when you say you want to integrate it into SQLite, it's this code right here. So this is a wrapper around the machine learning code that exposes it as a SQLite function.
One day this will all be Rust.
It is written in C, yeah. And this is the actual wrapper here, SQL beta dot big function that exposes it. And if you actually want to run, if you want to see this machine learning class actually run,
Yeah.
find the expose game for it.
And if you're not familiar with what some of this code is doing, it's a database engine, so it uses SQL, okay? And Evan, this is right up your alley. One of the beautiful things about some database engines, really good ones like Postgres, is that you can actually implement your own database functions and add it to the engine. So a long time ago, I did a network mapping tool that had an IP address data type. This doesn't exist in SQL. And you could do things like select whether or not an IP address was in a particular subnet, because it's a relatively easy thing to do. You just imagine it, the subnet as a group of a bunch of addresses, a set of addresses, and then you can do like set operations as SQL, likes to do for a lot of things with IP addresses. And in his case, he's actually implemented a interface, a set of functions that allow him to update and manipulate his model in SQL.
SQL, yeah. So this is the actual SQL code that calls the machine learning classifier in SQL right there. I can't reproduce. Okay. This custom SQLite compiled to WebAssembly actually contains the machine learning function right here, but it doesn't actually. I can't reproduce the input. The inputs are actually opaque C arrays as SQL binary blobs. So if I can call the function here, but it's just going to error because the inputs are incorrect. It's supposed to take how many? 1, 2, 3, 4, 5, 6 inputs. So I'll just give it 6 inputs. So you can see it try to run the classifier. You can see it right here. So when it runs it, it's out of memory because these inputs are incorrect. One of them tells it one of them is a pointer to a C array in memory, and obviously one of these pointers are all null. So it's giving a memory error. About the symbol right now. Did that answer your question about calling? Do you want to know more about it?
I thought that was a really good showing of the interface between the engine and the basically functions that you've added.
Yeah, so this thing is actually calling this, this thing is calling this interface, which is actually calling this machine learning program right here. That's what you can see. Did that answer your question, Evan? And also, and you were asking about what's the point about the risk management. I didn't model the risk. Okay, I'll give you.
But the risk management is very much a financial topic. Let's skip it and
Okay.
get into the technical ones.
All right.
I mean, unless there's somebody who's dying to hear about risk management.
So here it runs it. So see, after 15 minutes, I'm sorry, every 15 seconds it updates. If we, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. It recalculates everything. And if something is like I'll show you this bracket here, right? It's currently supposed to hold at least 61% of its money to work in stocks. If it currently fell below that, say it went down to 60, then it would start. They would look at the total stocks that machine learning program I gave you a while ago chose, and it would buy one from that total stocks. There's some other ranking factors.
So your algorithm is trying to keep a constant value in the accounts.
Yeah.
There's a time trading technique where if you try to keep a constant value inside accounts, you effectively can always buy low and sell high, because if you're trying to keep like $10,000 in Cisco stock, and Cisco stock goes down, then the value of your Cisco stock account will be $7,000, and you'll buy another 3. And then if it jumps up to where the value of your account, however much stock is in it, is now $15,000, then you'll sell off 5,000, and that way your algorithm is guaranteed to always, buy low and sell high based off of how much volume of cash you keep in that account.
So, so 65 is your target, but what's your threshold? Plus or minus 5%
No,
of that, or?
no, this is a threshold. So it should have at least 61% of its money in cash
61%.
in stocks. But it should have no more than 66% of it.
Okay.
So those are the thresholds.
61.
It actually has a threshold.
Thanks.
These thresholds change according to, I'll show you.
What's the point of having cash in use?
Huh? So in case the market goes down even more.
You want to buy it?
Yeah. See, that has cash on hand. So it's going back to here, right? See, when SPY goes down here, right? What happens? The thresholds, the threshold to buy goes up. So say here was 66. The threshold was 61 to 66%. When it goes down here, the threshold goes up to maybe 70% to 71%. It starts buying, right? It could theoretically max out, but the market has to like really crash for it to go to 100%. And here, right, it goes back to 61% because it's at equilibrium. Actually, equilibrium is supposed to be 66%. And then as you see, when SPY goes up, then the threshold goes down to 50%. And I'm sorry if you don't do it. But the thresholds change based on whether it thinks it's a good time to buy higher or so.
In your GitHub repo,
But
I'm assuming you can't share the GitHub repo because you've got connection info, or did you omit that?
I omit that,
Okay.
but it's proprietary information
Oh,
for
okay.
now. That's
Alright.
fine. So this is obviously what you're supposed to buy low, right? So this is
Correct.
when you're supposed to buy, right?
When people panic, that's when you take advantage.
This is the buy low, because when it's buy low, basically the threshold goes up. So instead of holding 60% of it in stocks, it goes up to 70%.
But what I'm confused about is because you keep, this is like the third or fourth time. Let's say that you don't have the data on the future and you're at the buy low point, right? You're right there.
Oh no, this thing is calculated from past data. It's not future. This blue line,
It's supposed to know the future.
this
yeah.
blue line is a guess of the future. It's actually in hindsight. It's so simple.
To make the chart, it
At
includes
this
all the
point-
data,
at this
but
point in
So some
time,
of this
I
requires
only-
some
I only see
machine
this.
learning knowledge.
What?
Do you mind if I give a very stupid, simple machine learning example for the people who want to figure out how the past relates to the future?
But
Well,
let's
finish your presentation then, and I'll cover it.
Okay.
how far are you along?
So at this point right here, right, all the bot knows is this thing. It calculated this blue line right there.
Okay.
Okay, this blue line, it's what it thinks is the equilibrium. It doesn't know, it thinks so. So based on this blue line, it sees that this Y is above the blue line, right?
Right.
So this is an indication to the bot that it should sell high. Does that make sense?
Yes.
It doesn't see this. Right now, at this point in time, all it sees is this.
Okay.
And then when I move a little bit more in the future, it sees this, right? Let's say at this point. It sees this, right? So this blue line was calculated, right? From machine learning, well, not machine, from technical analysis. It sees the blue line is here, and it sees the SPY is down here, right? So according to what it's calculated, it sees from there, it should buy low. Does that make sense?
Yeah, I suppose it makes sense to me, but the only thing that I don't understand is like, I've had this, let me give you a case in point. This is what was explained to me like before, when I went to one of these financial talks about this same thing, right? It was like, okay, back in the 90s, there was a trend where, in the early 90s anyway, the trades used to be exploitable because the people doing them were humans. And humans have a tendency to buy disproportionately at a specific number and sell disproportionately at a specific number. For instance, if it drops below $100, most people sell. Because if they buy above $100, now they feel like they're in the danger zone, psychologically.
Mm-hmm.
So an algorithm would exploit the psychology of humans. What my question is I don't understand with those red lines, is there any rhythm or reason for it to change directions and start to go up or to go back down?
No,
what is
that's
it exploiting underneath? What is it learning
reversion
from?
to the mean. That's the thesis.
Yeah, isn't it a zero knowledge, it's only statistical.
Okay, that's what I don't know. I'm too math stupid to understand
So,
that. I think that's like a big part
So
of it.
what's hidden behind that red line is basically he's built up a machine learning model that takes a look at the volume based off of its best estimate of pattern matching of prior events inside that stock. And so it'll take a look at the recent trades, still historical, everything else, and then it'll get an idea of like what its estimate of the current value should be, which will be wrong because no one predicts the future. But then he also has the actual Standard & Poor index over there to see what the market's doing overall. And so what he's doing is he's comparing his very temporary ephemeral calculations on what that stock might do because he's got a history of that stock that goes back 10 years and trying to compare it to the Standard & Poor index and making a decision based off of that with volume information that's not shown here.
You don't need volume information if you're using SPY because SPY has so much. Well, I use VBAC.
For your learning, you're using volume.
Yeah. But just to calculate, so this blue line is actually calculated from what I currently know at this point in time.
So I think what you're.
But this is basically the $100 thing. Right now it's at $100, and the market right now is at $80. So I'm thinking I should buy.
So I think what you're confused is basically the red line is the actual value from the past until today of that stock. And then the blue line is calculated by the model. And so it's taking a look at the difference between them because what I understand is the blue line is kind of giving you what a stable market would be.
Is the mean, is the reversion to the mean point? So SPY is at this point. My computer thinks this is too low. It thinks SPY should actually be at this point.
Based on the historical.
Based on historical information. Because my model believes SPY should be at this point and not this point, then it comes to the conclusion that the buys right now is going to buy low.
I feel like the algorithm is changeable by anybody who deploys it, right? So it's not an interesting.
I think I'm the only one that it doesn't think. I'm cool. I'm
Okay. My bot thinks SPY shouldn't be at this value. It thinks it shouldn't be at this value.
yeah, that much I get.
Okay.
Yeah.
And so what part of that don't you understand how I calculated?
Well, because what I don't get is
Because we're caught in a circle
Yeah.
on this item.
I don't think we're
And
gonna
I
get
don't
through it.
want to spend the rest of
I agree.
the meeting talking about something where, until like both sides wind up learning enough that they can move forward. I think teaching a little bit about the machine learning underneath it might move things forward. but I want to give the chance for you to wrap up your
Like that.
slide set.
Okay, it's wrapped up now already. So I
Okay.
showed you the dashboard, and the SPY predictions actually are just. So every end of every week I post the SPY predictions, and it's to help me enforce record tracking of the names.
All right, so who knows how machine learning works in a very general sense?
So what's the subreddit?
Okay, then I'm not
SQL
gonna.
map.
If you didn't raise your hand and you want to know, ask me privately later.
This is the subreddit for that.
For
software?
prediction, no, for the predictions. I just publish it so even if I lose all my data, I can see. So for the prediction today, it thinks, thought yesterday the SPY was go down. That was not true. It actually went up. Today, it thinks SPY will go down. That's actually true. So it was correct on that point. And tomorrow, it thinks the market will go up. And basically, based on this prediction, it also adjusts the brackets. So because today it predicted that the market was going to go down, the brackets were actually adjusted downwards because it's in anticipation everything was going to go down. I mean, the day before. Actually, forget what I just said. Let's look at tomorrow.
Let me just ask this question. Did you run any statistics on your estimates to see what your estimate accuracy is?
Yeah. So have accumulated data from have 140 data points predictions. And of those 140 predictions, 73 of them were right. So the accuracy is if it was completely random, it would be 50%. Right now it's 52%.
It's within the margin of completely random with
Yeah,
error
right now
estimates.
it is because the margin of error is 8% right
Yeah,
there.
and that's the problem with all the machine learning trading algorithms, is that it's just basically, unless you have a data set that really includes enough data points to where you can find something that triggers, you wind up working data that is insufficient to really give an accurate prediction. And so like a lot of the algorithmic trading, like people would used to use the candlesticks and they'd say something like, oh, once you see it drop, 20% you buy. Well, that really burned a lot of people when it dropped like 60% because there's a major market crash and things like that. There's no 100% clear fire formula. If there was, then no one would ever lose money in the market because they'd only trade those algorithms. The truth is that what's interesting about this one in my mind is that you used machine learning and you built it into an SQL database interface.
That's pretty cool.
Thank you. Okay, yeah. And so I showed you the internal.
My fingers are crossed you make money too, but that's not a Linux topic, so.
So far it's been making money historically, and it's been doing better than SPY in the market.
52%.
No. That's prediction. That's not actual returns. The actual returns I showed you a while ago. It was right here.
Okay, so you're effectively adjusting your returns to where you.
That was only over a 2-year period though.
Yeah,
Right.
so it's
2
only
years
Well, if
is
you take a look at the
barely in the
predictions,
finance
if
market.
you took the early predictions, it was like wrong.
It was-
the first half of the data set.
It really seems to me, looking at how those graphs are overlaid and based on the math you're using in standard deviations, what you've effectively created is just a moving average of the market. And that's
And we
exactly what it looks like, when it's high, it's a little lower, when it's low, it's a little bit higher.
Yep. Moving average and the VWAP. And also, and there's some other things, but mainly it's the VWAP.
My guess would be is if you were in 50 years or almost exactly equal what the stock is going to be average wise.
Yeah, and the machine learning component is simply used to pick the stocks when it makes a decision to buy. That makes sense. So the decision to whether to buy or sell is based on the VWAP and the SMA, simple moving average. But when it makes a decision to buy, then it relies on machine learning to figure out which stocks it should buy. Does that make sense? I'm sorry. Anyway.
Yeah, because you're trying to
Yeah.
select the ones that your machine learning model thinks.
Yeah. And basically, my talk is done.
Cool.